All right. Dixie Office Supplies finds that its sales force drives an average of 1,200 miles per month per person, with a standard deviation of 150 miles. We've done a similar example to this, well, almost the exact same actually. I think it even has the same number of miles. So I'm not going to do this first part because we already did that one. But part B here, find the number of miles driven by the 70th percentile. We hadn't done that one yet. So here we have our sales force. And our mean number of miles driven here is 1,200. And we're trying to figure out, the 70th percentile means 70% drive less. So let's see, 50%, the 50th percentile would be right at the mean, 70th percentile would be a little bit farther over. So I'm going to go ahead and call it here and say that this area in total here is 0.7, because that's the 70th percentile. And we're trying to figure out what is this, not z, what is this x score? What number of miles driven is the 70th percentile? So we have a total area to the left. We're trying to figure out cutoff, which means we want to do inverse norm. The area to the left is 0.7, our mean is 1,200, and our standard deviation is 150. So that means I can type that into my calculator. We'll do inverse norm, 0.7, 1,200, 150. And we get the 70th percentile, 1279. Yeah. That means if you drive 1,279 miles in this particular company, that 70% of the people in this company drive less than you. Conversely, 30% drive more than you. But you are the 70th percentile here. If we wanted to find the shortest and the longest lengths driven by the middle 95% of the sales force, well, the middle 95%, so maybe they're saying a certain, we want the total area here should be 0.95. So they're trying to figure out the vast majority of people in the company drive within these two bounds. Kind of trying to figure out how to ignore the outliers, the outermost 5%. But if there's 5% outside of the 95%, it needs to be split evenly between these two. So that means over here there should be 0.025, and over here there should also be 0.025. 2.5% to the left, and 2.5% to the right. That way, in total, this all sums to 1, and it's balanced. When you're talking about the middle 95%, you kind of have to do this. You have to use your complement rule and then divide that by 2 to figure out what each of the tails should end up being. So if I'm trying to find out the shortest and longest lengths driven here, that means the area to the left of this cutoff is 0.025. So I know the area to the left. I'm trying to find the cutoff, which means I want inverse norm. 0.025, 1,200, 150. That'll give us this number. Inverse norm, 0.025, 1,200, 150. Oops. Should be 150. So that means 906 miles. That is the bottom cutoff here. And inverse norm for this upper cutoff, it looks like 97.5% lie to the left. And you could get that either by taking the 0.025 plus the 0.95 here to get 0.975, or by using your complement rule and seeing that there's 0.025 to the right. So when I do this one, I'm just going to do second enter to call that previous entry up and change this to 0.975. We get 1494. So 95% of the sales force, the middle 95% of the sales force, drive between 906 and 1494 miles. If you drive less than 906 miles or more than 1494 miles, that means you're one of those out, the top 2.5% or the bottom 2.5%. You're not in the middle 95% here.